So without much further ado, this is Denis. He's yet another great alum, actually current great member, and he's going to be talking about targeted attacks via ISPs.
Yeah, I would. Good day to everyone who chose this session. I'm Denis, and I don't do it, targeted malware reverse engineering for 5 days already, but I promised you to return to it after that. And this man edited my abstract for VB, so he's also in charge of me is here. So kudos to Juan. Okay, why I'm choosing this topic for the VB? Later, it's frightened me a little. Maybe last 2 years, I observed maybe too many initial infection, providing in some transparent way for end user, for the target. Using ISP channels, using some services, and user couldn't reject. They have to. We all have to use our ISPs. We all have to use some other services. That's why next 30 minutes, I would do some observation of the current methods, overtaking, maybe use some leverages on the ISP level, or some leverages on the level of the Governmental Digital Services Portal, so would cover 3 cases. First of them, we are luckily in the spring of 2019. We have from my point of view, very good sample of such an initial infection, such an attack, such a malware. We call it Reductor, but it's not our name. It's named from the original developers. They mention it as usual in a PDB. We observed it one of the samples, but it was not just a PDB, but passed to the Git, developer's Git. I suppose not every malware author used system control version to develop a malware. Okay, so we got the name, the Reductor. And before I promise you to return to ISP topic, we would dive a little bit to the functionality of the Reductor first, and then return to the question why we're thinking something happened on a network level with a target network channel. I like this technical trick they are applying. And after it, we still, StrongPity, I suppose everybody knows about the StrongPity, not a new one, but still in 2019, we still observe they are quite active. So that's why let's update our knowledge about the current stuff, and they also have some connection to some leverages on the local internet service providers. And then, to show you not the only ISPs as a server the end user consumes, we will speak about one case of the national data center in which hosted, in this Asian country, hosted also governmental digital services. Once again, if you're a citizen of this country, you have to visit this portal and to use it with a data center. Okay, let us start. Let us start with the Reductor. It all starts with COMpfun malware. COMpfun is known since 2014, and GData covered it in a report. It's still available. You could find it. COMpfun has quite innovative back then way to get a persistence through the COM object class ID to get persistence in browsers. But it's already known. It's already known for 5 years already. GData, to my knowledge, don't attribute it to anyone, never. We also back then attributed it based on a victim's similarity, attributed to Turla actor. This is it. When you are and how story starts, our attribution engine found some new malware. It's not a COMpfun, but for sure have too many code similarities. So we are quite sure this new malware we call Reductor was compiled by the developer who has an access to the same code base. So you could say by the same developers. We are quite sure in it. And everybody in every presentation want to know something about the attribution. Let's make it this way. We are sure with Reductor authors are the same authors with the COMpfun, and COMpfun several years ago with a medium confidence we attribute to Turla because of the victim's similarity. This is it. And we start to analyze this new malware written by the same authors. What we found? First, as usual, we found some auxiliary modules to decrypt, to avoid detection, to escalate the privileges, okay, some auxiliary stuff. And as a result, was decrypted, as usual in memory, the reductor part. It was a Trojan, full-fledged Trojan, and I really like it. I could tell you technically why I'm liking it. From my point of view, the good developer thinking about algorithms and the best developers thinking about the data structures. And the data structures in this reductor case was quite perfect. So it was some architecture in mind was behind from my point of view. But the question appears, COMpfun itself is a full-fledged Trojan remote administration tool. What for? And also we registered some cases. In one method of spreading, only one method of spreading, the reductor appears on victims of a COMpfun. So they use a COMpfun in this case is like a downloader. For sure, as a remote administration tool, it has an ability to download another files and run it. So interesting. They have one full-fledged Trojan to download auxiliary modules and another remote administration tool. Why? And we start to analyze the functionality of the reductor. By the way, don't be afraid of this technical stuff. For one who want to dive deeper into reductor functionality, an hour ago, we published a technical analysis on our securelist.com, and you could read in your tempo about all these technical functions. So when we analyze the reductor, what we found? We found it mostly, of course, it could download file, upload, run it, etc., but as well, a lot of efforts with time by these developers was into these digital certificates. Reductor could install digital certificates and also do something with TLS traffic. So the answer to the question why the developer developed the second Trojan, I think they have some problem with TLS, with encrypted traffic. If the target visited some HTTPS, google.com, whatever. Sorry, Juan, not Google. Some HTTPS site, not yours. Maybe ours, securelist.com, also HTTPS. And they have some problem to read the traffic because of the encryption level. How could the malefactors manage it? Good old keylogging, possible, but not so convenient and maybe too loud for current security products. Anyway, whatever method of keylogging they use, it's hooks. They have to set up hooks, and every secure product, I suppose, would catch them. What else? Try to decrypt? Maybe not with TLS 1.3, maybe not with the current level of the HTTPS protocol. They could install certificates to facilitate manage the middle attack. Okay, it's a way. They could install, malware could install it, and Reductor did it as well. But imagine what their target has quite a big corporate network. And they don't interesting to get all the TLS traffic. They only want to are interested in this host, and this. Don't want to distinguish 3 hosts of interesting among all of the thousands hosts on the victim side. They have to mark. They have to change TLS packet somehow, right? Make some marking. This is a packet of interest. How to do it? Mini filter network driver, it's possible, but maybe once again too loud. Some malefactors choose this way, writing NDIS proxy or finding already written by third parties and this proxy driver. But Reductor authors invent, and here we go to the, for me, most exciting thing in this malware. They invent some methods, not even touch the network packets, and solve these 2 problems. First problem, how they could obtain TLS traffic. Second, how could they mark the traffic of interest? What they do? It's all started, I'm happy in the previous presentation, also from TLS was covered. And if you take your Wireshark and start your TLS communication and take a look at the packets, you will see it started with a handshake, right? Handshake packets. And you also would see in the very first packet of it, you would see client hello field. What is client hello? It has almost nothing to do with the cryptography. If you change it to something else, you wouldn't affect cryptography much. Your communication later on would still be encrypted between the client and the server. But it's the first part of the handshake. to let the server know, okay, let us communicate with encrypted way, okay, I don't mind. Let us use the certificates, etc., like a handshake. And this field is a random. Random 32 bytes in the client hello. And our Reductor developers decide to use this field to mark this traffic. And what they did, which function are in charge of filling this field? It's a PRNG function, pseudo-random number generators on the system. Not so many of them. In case of Firefox, Firefox would use an SS3 library and some function with the name pk11, generate random. And if the target used another browser, for example, in case of Chrome, some function from the chrome.dll would be used. By the way, if you take a look at the size of this Chrome DLL, I would bet you don't want to reverse it. But anyway, we just compile in one huge file, and this random number generator, maybe also from the Chromium library, don't know so far. So they also include into Chrome DLL. And speaking about the Windows API, if we are not with the browser, but with the system processes, also not much choice, a little outdated crypt random. I was surprised, by the way, it's also already outdated. Now, Microsoft, if you open MSDN, I suppose the function from Advanced IP32, you would find, don't use it anymore, outdated a little bit. And so now trend is to use bcrypt random from the bcrypt DLL. Not much to patch, right? And what developers of this malware decide to do? They patched corresponding function inside the memory of the corresponding process, Firefox, Chrome, etc. They patch it and change how this random number is generated. What was the result after it? And for sure, I choose Firefox. For Firefox, I have the source code, it's easier to analyze. I don't have to reverse chrome.dll, several megabytes long. And I saw the following chain. To make the client hello in the TLS communication, it's implementing function SSL3, get new random. Okay, got it. But before it, who calls this setup client hello? Get new random, sorry, it's TLS-13 setup client hello. It's just a function called in the very beginning of TLS communication. Who called it? It calls SL3 get new random, and in its turn, it called our pk11 generate random from the previous slide. So, in the result of patching of the one function in the Firefox process memory, they would affect the content of the client hello in the very first TLS communication handshake. What for? What they put in this field? As I mentioned, encryption wouldn't suffer. They still couldn't decrypt this communication. So that change one field. Everybody who has access to this network channel between the server and client could read. It's readable, quite readable. You could see in your Wireshark. And the crucial thing here, it's a first packet. So all this session of TLS communication goes after this packet. What they put into it? They put some interesting stuff. They keep first 4 bytes of initial random data. They use this random 4 bytes as an initial XOR key. After it, put some magic number, I suppose just to check the decryption is all right, and 2 unique ID for the target. One unique ID is related to the counted based on the installed certificates, installed X509 certificates, and second one is connected to the very specific hardware IDs like BIOS number, video BIOS number, etc., etc. So two very special, 2 very unique values for every target. What they do, and also provide some simple algorithm. They don't just do 4 bytes XOR, they change XOR key on every round. And they also now have, once again, quite random, 32 bytes, still encrypted with the XOR-based algorithm, but inside it, in decrypted form, there are 2 unique IDs. Okay, seems like a mark for the target, even if the target is after NAT, is after some proxy in a corporate target. They do it. And also below, it's a certificate. Certificate is inside Reductor's body. and they add it also to the victim's system. It's in the decoded and installed form. You could see it here. So they fulfill so far 2 tasks. Add certificate to facilitate MITM, I expect, when I see certificate installation unexpected, and also some tricky way of the mark the traffic from the infected host. What next? What next? They also have some fun, as usual. This time, the fun is some, okay, call it Easter eggs. It's one control server, COMpfun.net. COMpfun in nowadays is quite known name, right, for the malware. We have a G-data report for 5 years already. But they choose one of the control servers for the COMpfun with the same name. And also, once they run a process, like from the other user, and they use like a username, user access control, UAC, as a domain name is, and as a password useless. So UAC is useless in the malware as well. I like such tricks inside the malware. Why we are thinking something is happening between the targeted machine and the server. I remember I mentioned infection for the COMpfun is not the only one. The second way is a little more trickier. Our telemetry show us infected installers. And with infected installers in Spring, we see the URLs like here, but no more installers is no more available on this virus website. So we couldn't check, was it infected on the virus website or was it infected only on the client side? That's why in the first report, we don't write they could infect something on the flight. We couldn't be 100% sure in it. But later, in July, we keep tracking this malware, and we saw another virus website with another URL, and this time installers were accessible. We downloaded, we check it, it's clean. So once again, here on the virus website, some clean installers, and on the target side, it's already infected. So obviously, something happened in a way. I don't know what happened between it, but from my point of view, the most obvious way, the most obvious point to do something between these 2 hosts is ISP, because it would for sure go through target's ISP. Yes, they could maybe try to find another server from which traffic would go through, but I think here I'm quite sure something in a way, and I assume ISP is also has some host on which some changes in this installer happened. This is this. Okay, now we are returning, we are describing a little technical abilities of the reductor. Also for those who are interested to understand it deeper, please go to secure list. And I also describe why we are thinking something happened on the network, on level of network channel. Let's go further. I promise StrongPity, which is still active. StrongPity is quite, in terms of the malware, it's quite, maybe not simple, but quite normal. They have the module to gather the data on the host, and they have the network module to send some encrypted files to the control server. This is it. So 2 modules and some files provided on some files on the target machine. And also the network protocol is quite usual. They have some magic numbers, so it's quite understandable normal malware. The strong part of the StrongPity is not the data gathering and it's not the network protocol. It's how they do initial infection. And here kudos goes to the Citizen Lab, and thanks to them, they research, where I think you are read about it, server side on the StrongPity is a Sandvine Citizen Lab bought the used Sandvine hardware, and what is it's actually a DPI system, deep packet inspection system, and which owner of it, ISP, I could say, could set some rules. If this host of interest, ask for these files, please do following. For example, provide different file instead of the initial one. So for example, target goes for the WinRAR installer, but get something in additional. Here it's on a sendline, it's implemented as HTTP redirection. So it's just the HTTP 307 response from the server, and another URL goes of the new infected installer, what came from another URL. As you saw previously in our telemetry, our reductor guys, just the URL was quite the, I could say, legit virus website, right? They don't change, don't redirect on HTTP level. So it's they're working, I suppose, on a TCP level. But also, it's still one more APT working on an ISP level and still active in September. We still just get new, very format in the same way names of the control service. So new and new of them even in September. And the last sample, the third example of it, it's not only ISPs, other places for the citizens to visit. Also, now in many countries, governmental portals for the digital services exist. In Russia, for example, it's gosuslugi.ru. In other countries, I expect in your country you have your own. And once we described such a case in which we call this actor lucky mouse. I suppose it's APT27, it's a synonym for the lucky mouse as well. And in terms of the malware, once again, it's quite typical for the Chinese-speaking actors, a lot of layers of decryption, so injection into memory, as a result, the full-fledged Trojan. Once again, some usage of the meterpreter, you could see Shikata Ganai, defuscation. Okay, in terms of malware, it's understandable, but what was the interesting part of this? With time, they found, to communicate with the control server, they searched on a GitHub and found Blackbone. Who observed Blackbone in the malware? No, no one. Blackbone, it's accessible in source code, like everything on a GitHub, and it's like I mentioned in the very beginning, it's a mini filter network driver, so it's in this proxy. And they want to embed it communication into DNS protocol and use this backbone third party, rewrite it a little bit and use it in their own operation, providing something like this. They install with a custom installer a proxy driver. But by the way, they also steal the digital certificate to sign this driver, and this Trojan working together to communicate through the DNS channel. Okay, how it's now time to connect it somehow to this national data center, right? It was the victim. And I think it's for the malefactors, it's quite wise to choose some victim because they use it not only to collect the data from this valuable source of knowledge, they also did a waterholing campaign using these pages of the governmental web services hosted in this data center. So just a small malicious JavaScript, and they get the initial foothold on a countryscape in this Asian country. So not only ISPs, but also some portals are also crucial as an entry point for them. So time to wrap up all this. And what I think it's here is crucial, what you don't have to be the final victim of malefactors to invest a lot of efforts into your company. We saw it in case like Asus Update, they invest a lot of efforts to infect them, but it wasn't the target. It was just the step to the targets. And here we also see some examples of it. In case of Reductor, I have a feeling with the managers of these programmers, don't push them too hard. Please provide new anti-detection, decrypted, etc. They just gave them the ability to invent some new method. And as a result, I hope I could describe to you all this genuineness of this method. I haven't seen such a method before to mark these packets and to get such a result of marking the packets and install the certificates. So this is it. With it, sometimes they wisely choose a point to hit, like national data centers. Sometimes they have some leverages, I suppose, on ISPs. And here, with 3 samples I want to give, if you have some questions, please fire it up. I'm done. Thank you. Thanks for your attention.